And hello all, welcome. It's Mr. Callan helping you out with the assignment for May 15th, entitled Estimate Roots, Day 2. Looking at Google Classroom, hey, I've noticed some of you aren't quite sure which assignments are completed, which are not. Look for a difference in colors. You'll see some of mine here look like pink and gray. Yours might look like dark gray and light gray. That's how you know which assignments are complete and which assignments still are missing. So back to Friday, May 15th, Estimate Roots Day 2. Read today's overview, optional live teaching session 2 to 3. Watch the video, that's what you're doing right now, and complete the assignment. Overview for, again, Friday, May 15th. Learning objective, I will use Roots to estimate solutions to the nearest integer. We're going to both compare numbers, whether they be rational or irrational. We're also going to solve problems using the estimation of square and cube roots. Now, to review the exit problems from a couple days ago, kind of surprised by these, not as solid as our team usually is used to. For instance, the first question, how are all the problems similar? Many people said they all have roots. On the other hand, I was surprised nobody said, look, none of the roots were perfect numbers, or should we say integers. In fact, all of them were crazy, ugly, irrational numbers, and therefore, if you look carefully at the directions, it said estimate, come up with the nearest integer. How are they different? Many people said they have different numbers, different answers. Some have decimals or fractions. But I was surprised that nobody pointed out that some of the roots were second or square roots, others of the roots were third or cube roots. And yes, there are fourth, fifth roots and beyond. You don't have to worry about those quite till high school, but surprised nobody observed that. Now, when it came to the instructions, I'm going to go ahead and pause and highlight some instructions for you. So here I go with the steps and an example right next to it. So let's say we want to find the square or second root of 118. Well, step number 1, make a compound inequality, inequality with 2 or more inequality statements, where there are 2 perfect squares or perfect cubes, one on each side. So for instance, 100 is smaller than 118. 118 is also smaller than 121. Now, some of you might be asking, what's with the 100 and the 121? Why use those numbers? Well, take a look at step 2. Step 2 says to take the root of each of those numbers in the number sentence. And so we see the square root radical symbol over each of the numbers. Step 3, go ahead and simplify. Now, this is why we chose those special numbers. The second or square root of 100 is exactly 10. The second or square root of 121 is precisely 11. What about the second or square root of 118? Well, it's some crazy, ugly, irrational number, so we can't quite simplify that, but at least we know it is somewhere between 10 and 11. It'll be 10 point something. Step 4, determine which integer is closer. So if you find the difference from 118 to 100, well, that would take 18 steps. For some reason, I wrote 10 there. That's clearly not 10. Meanwhile, if we find the difference from 118 to 121, of course, take the absolute value, you'd realize that it is 3 steps away, which is much closer than 18 steps. So step number 5, write your final number sentence. If we were to estimate the square root of 118, very close to 10, but even closer to 11. 11 is the closest integer. Now let's go ahead and take that number, number sense with us as we go to today's assignment. You'll see estimate roots. I'm going to go ahead and blot out some of the answers so that we cannot see them anymore. And let's begin with comparing. So let's take a look at number 13. So the first directions, they ask us to order these numbers from least to greatest. Now, we know how 8 compares to 10. Clearly, 8 is smaller. But then what about something like the square root of 61? Square root of 61 would be about how much? So here's where we want to take that number sense that we just built, and let's come up with a good estimate. Now, we know that 61 is a little bit larger than 49, a little bit smaller than 64. And you know where we're heading now. Let's go ahead and take the square root of each of these numbers. So we have another compound inequality. And why did we use those numbers? Well, because the square root of 49 is 7 and the square root of 64 is 8. And what's the square root of 62? Actually, I don't know. It's something crazy, ugly, irrational, but at least we know it's a little bit larger than 7, a little bit smaller than 8. At this point, let's go ahead and figure out which it's closer to. If we examine 61 to 49, we notice that is 12 units away. Meanwhile, 61 to 64 is only 3 units away. Clearly, it's closer here, so it would be closer to 8. Maybe we say 7.8. Maybe we would say 7.9. So I'm going to go ahead and write that the square root of 61 is awfully close to 7.8, 7 and 8/10. Now let's go ahead and kind of figure out the same thing as we examine the square root of 71. So 71, a little bit larger than 64, a little bit smaller than 81. And if you're wondering where those numbers came from, take a look as we rewrite the compound inequality so that we take the square root of 64. Well, that's 8. Square root of 81. Well, that's 9. What about the square root of 71? I don't know, something crazy, ugly, irrational, but at least we know it's going to be 8 point something. Now let's go ahead and examine and analyze which it's going to be closer to. It's going to be 10 units away from 81, but it's only 7 units away from 64. So almost in the middle, but not quite. And therefore I might say 8.3, maybe 8 and 4/10 would be a little better. Either one of those is fine because both of them will serve our purposes. Remember, please, that what we were originally asked to do is to order them from least to greatest. So let me build a little number line here. Now on this number line, we can immediately plot where 8 is and where 10 is. The others were a little more challenging to figure out. But what we have imagined here, that the square root of 71, a little larger than 8, almost halfway between 8 and 9. Meanwhile, the square root of 61 was pretty stinking close to 8, but a little less than that. In fact, we said 7 and 8/10, 7 and 9/10. So now for those of us who are fairly visual, we can see a little clearer now how to compare these numbers. We see that the smallest of these four numbers will be the square root of 61. Next, beyond that, we have 8 wholes. The next larger number would be the square root of 71. And finally, of these four numbers, the largest of those numbers would be 10 wholes. So what we have found is we can write a compound inequality stating that the square root of 61 is smaller than 8. 8 is less than the square root of 71, and the square root of 71 is less than 10. And we've just put these in order from least to greatest. If you wish, you can go ahead and pause the video now, start up 14 and 15 using that number sense that we just used for 13. Meanwhile, let's go on. Problems down below. Estimate the solution or solutions. Notice that S is in parentheses. So there could be one solution. There could be more than one solution. We're going to estimate it to the nearest integer. And so here we go. Remember that when we're trying to find an answer, a solution to an equation, a solution is a number or number that makes a statement true. In other words, what number, when multiplied by itself, that's what that second power means, will be precisely 61. Well, let's use our inverse operations here. We know to get rid of addition, we subtract. We know to get rid of multiply, we divide. What about to get rid of a power? Well, to get rid of a second power, we're going to take the second or square root. And of course, we have to be fair to both sides. But if we go back a few months to what we've learned about second or square roots with equations, I'm going to write this little plus or minus there. Now, some of you might be wondering where'd that come from. We'll talk about that in a moment after we check our answer. Please notice that when we take a second or square root of a second or square power, they are inverse operations. They cancel out. Yay, good. That's exactly what we wanted. We wanted to know what is D equal to. But then we get to the square root of 61, which might sound a little familiar in case you were paying attention up above. Let's go ahead and now figure out what the second or square root of 61 is approximately equal. So the first thing we're going to do is set up a compound inequality with two perfect squares on either side. Then we're going to take the square root of each of these numbers. Noticing here that the square root of 49 is perfect. It is 7 wholes. Square root of 64 is 8 wholes. Square root of 61, I don't know, but at least we know it's between 7 and 8. Now we go ahead and figure out which it's closer to. It's 12 units away there. It's only 3 units away here. So it's going to be closer to 8. Now, if all I did was write my answer as D is approximately 8, I would say that's a pretty good answer, but I'm not so sure that's the best answer. So let's go ahead back to the original equation and let's just check ourselves here. If I were to take some number to the second power, and let's go ahead and substitute in that number. I'm going to write 8 in here, and I'm going to put a little question mark. What is 8 times 8? 8 times 8 is 64. Yeah, that's pretty close to 61. However, is there another integer in which that would work? And if you notice, if we were to actually multiply -8 times another -8, well, 8 -8s would be -64, but this actually tells us to take the opposite of all those -8s. Well, darn. 64 is also about 61. So that is why we have to say there are not just one answer, there's 2 possible solutions. You are welcome to write D is about 8 or D is about -8. Mathematicians like to write things in an efficient manner, which is why many of us will simply put that plus or minus in front of the 8. So, turns out there are 2 solutions here. I want you asking yourself, will there also be 2 solutions to the following problems, 17 and 18? Meanwhile, I'm going to go ahead and carry on to the back side and do another example, same directions, estimate the solution of each equation to the nearest integer. I could pick any one of those, but I think I'm going to pick problem number 20. Now for problem number 20, our goal is to find what is A equal to. This, however, might look a little similar, might look a little different than the problem up above. Again, to get rid of addition, we subtract. To get rid of divide, we multiply. To get rid of a power, we take its root. That would be the inverse operation. But we have to be fair to both sides. Now, a big question that I'm going to leave you with is, will there be only one answer or will there be 2 answers? Is this similar to the problem we just worked on or is it different? Keep that in mind. I'll put a little question mark here as we go along. Now we know that, as we said, inverse operations cancel out, so a third root and a third power cancel. Good, that is exactly what we want. What about the cube root of 200? That is not a perfect cube. If I start making a list of the perfect cubes, 0 cubed, 1 cubed, 2 times another 2 is 8, 3 times another 3, and so on. We can continue building a list. However, let's see, 343 maybe? 512 perhaps, all the way to 1,000 and beyond. Well, I think I can stop right there because 200 is clearly somewhere in between these 2 perfect cubes. So let's go ahead and set up a compound inequality. 200 is smaller than 216. It is larger than 125. Now, for those of you wondering, why would we choose those numbers? Why not choose 199 and 201? Well, let's rewrite the inequality taking the cube or third root of each. And now you might realize why we chose those numbers. The cube root of 125 is 5. Cube root of 216 is 6. The cube root of 200, I don't know. It's something crazy, ugly, irrational. In fact, it's going to be 5 point something. Now let's consider which is it going to be closer to. 200 to 125, that's 75 units or steps away. On the other hand, 200 to 216, it's only 16. Therefore, it is going to be closer to 6. And so I'll write my, wait a second. We have to come back here and say, wait a sec. Can it be both positive and negative 6? So let's go ahead and start checking our work here. Let's go ahead and substitute in 6. Is 6 times itself? Well, 6 times another 6, 216. And yeah, that's pretty stinking close. We were asked to estimate, so let's give that a true. However, let's take a look at -6 times -6 times another -6. Now, opposite of a negative makes a positive here, and then 36 groups, 36 sets of -6. Wait a second. -216 equal to 200. That is false. So back to our question, will there be one solution or 2 solutions? Because this is a third power, there cannot be 2 solutions here. There's one and only one solution, and that solution will be +6. So continue thinking about that as you go through the rest of those problems. Will there be one solution, or is it possible that there are two solutions to these equations? Now, of course, we have seen equations also where there are no solutions at all. We've seen equations where there are infinitely many, but the key for today is there one or are there two? Now, I could stop here. You could stop here and continue the assignment. I think I'm going to do one more problem. We're going to talk about how to use what we've just learned in real life. So let's say we really have a square. We got 40 square inches. The question says, use the formula for the area of the square. Area is equal to side to the second power, side squared, where s is the length of a side. Estimate the length for each side. In other words, what would each of those side lengths be? Now remember, we don't say length times width because for a square, it would be side times side, which is where side squared comes from. Now, what is it we have and what is it we don't know? It gives us the actual area. The question asks us, okay, what's each side going to be? In other words, we'd like to solve this equation. So to get rid of a second power, we'll go ahead and take the second root from both sides. Keep our equation fair and balanced. We've said before that when taking second roots, there are often two answers. More on that in a bit. But we know that the second root of a second power are inverse operations. Good. This is going to tell us exactly what it... Oh, no, square root of 40 is not a perfect integer. So we go ahead and we use our number sense again. 40 is a little bigger than 36, a little smaller than 49. So if we were to rewrite this compound inequality, we could rewrite it with the square root of each. Square root of 36 is 6, square root of 49 is 7, the square root of 40 is some crazy, ugly, irrational number, but at least we know it's going to be 6 point some. Now, it's only 4 units away here. It is 9 units away here. Not that either are incredibly far away, but this is going to be closer to 6. And so we will go ahead and we will write our answer to be each side is about, not exactly, but about equal to 6 inches. Now, wait a second. Can you have negative? No, you cannot have negative inches there. There's no such thing as negative inches in terms of a measurement. So our final answer is that each length is going to be approximately 6 inches. Take that. Maybe that'll help you with number 24. Using our number sense to approximate a crazy, ugly, irrational root, whether it's a square root, a cube root, or whatnot. Take your time, folks. Do well. Let me know if I can help. Thank you.